All right, so today we have our first day of a type of proofs. Today is going to be algebraic proofs. So section 2.5, we're going to go through all these different properties, which I know is a lot, 12 new properties to kind of think of and use. But to be honest, most of them you already know. There's only really 3 that are going to be brand new for you. So go ahead and go through this list of 12 items, so A through L, and see if you can match up what property you think goes with which conditional statement. Pause the video. When you come back, let's see how you did. All right, I'm going to jump out of order here a little bit as we go through these. So hang tight. We're going to start with addition property of equality. An addition property of equality is going to belong to E. And what that says is that if we have A plus B, or A equals B, sorry, then we can add a C to both sides, which you guys know, right? If we have x minus 2 equals 7, then our step to solve that is to add the same thing to both sides. So that's exactly what that one's showing by that we can add C to both sides. We can add 2 in this equation. Likewise, the subtraction, multiplication, and division properties are all very similar to that. So if we go over here, we can kind of start matching those up. So the division property of equality is going to go right here, right? So we're dividing by C on both sides. The subtraction property of equality is going to go right here when we subtract C on both sides. And the multiplication property of equality is going to go right here. So now we've done those 4. Now let's look at some other ones that you might be familiar with. And let's start with the distributive property. That's going to be right here. So distributive property is right here. Remember, that means we can say A times B and A times C. So we can distribute that. And substitution, you've also done a lot. So when we look over here at K, if A equals B, then B can be swapped in for any expression, right? So if we know A and B are the same thing, which let's say we know 2x plus y equals 7, and we know that y equals 3, then we can substitute or swap 3 in for y in any expression. So that one is going to be our substitution property. That's 8. And so we're left with the 3 new ones, and you'll kind of notice that there's reflexive, symmetric, and transitive properties. And these all have equalities and congruence, and that's just going to deal with the equal sign or congruent sign that you see in the problem. So let's jump back here. So the way I remember this is RST 1, 2, 3. And this is kind of the, it's not really an acronym, but the thing that goes through my head so I can remember which is what. So reflexive property is going to compare one geometric object or one thing. The symmetric property is going to compare 2 things, and the transitive property is going to compare 3 or more. So when I look at this one, and I start looking here at D, I see A equals A, right? A is the same thing, so that's going to compare just one thing. And because there's an equal sign, we have the reflexive property of equality right here. Whereas with C, we have one segment there. So segment AB is congruent to segment AB. That's just one thing, right? It's one segment, it's the same segment, so that's going to be the reflexive property of congruence. Once again, we have a congruent symbol there, and here we have an equality symbol there, so we know the difference between those 2. All right, symmetric property is now going to start looking at 2 different things. So we're going to say, if A equals B, then B equals A, and we can kind of flip them a little bit. So this one's going to be the symmetric property of equality, since we're dealing with an equal sign. And then if I flip over here, we have if P is congruent, angle P is congruent to angle Q, then angle Q is congruent to angle P. So there we go with our symmetric property of congruence. Now this leads to transitive. And transitive, another way I kind of think of that, if we're using our RST 1, 2, 3, is we've got our train. Right? We have a train, the domino effect. If A is equal to B, B equals C, C equals D, right? So let's say if A equals B, and B equals C, and C equals D, and D equals E, okay, then we know A equals 5, right? So then we know 5 is equal to B. Well, then we know if B is 5, then 5 is equal to C. 5 is then equal to D. And then if we plug in D over here, we have 5 equals E. So therefore, A has to equal E. And this is what we call the transitive property. And it's kind of the, a domino effect, right? If A equals B, and B equals C, and C equals D, and D is the same thing as E, then A has to equal E. So for this one, we're going to have our transitive property of congruence right here, which is almost the same thing, only we're using angles and congruency instead of equal signs. And our transitive property of equality is going to be number 7 right there. So of this entire list, the addition, subtraction, multiplication, division should be pretty familiar to you. Substitution, distributive should be pretty familiar. So reflexive, symmetric, and transitive are the only ones that are new. Reflexive, think of like a reflection in the mirror, right? You see yourself, you see an exact replica, right? A. All right, so let's get into some of these problems. So identify the property that justifies each statement. So M equals N, so N equals M. So go ahead, go through this list, see if you can figure it out. Pause the video, and when you're ready, come back. All right, so A is going to be, so first of all, I see 2 objects here. I see M and I see N. So that is right away going to throw me to symmetric property. And then I also see equal signs being used. So symmetric property of equality, 6. Angle ABC is congruent to angle ABC. I've got one geometric object here, right? It's an angle, one geometric object. So that leads me to reflexive. I have congruency. So 10, reflexive property of congruence. All right, C is definitely the trickiest one here. Okay, but I see one line segment, KL. And this is the same exact line segment. Right? LK is the same thing as KL. So this is only one geometric object, which means it's going to be the reflexive property. And then because of the congruency symbol, of congruence. So the reflexive property there. So even though KL looks like something different than LK, and it's looking more like the symmetric property, it's going to be reflexive because it's the same segment. So we're talking about one geometric object. D, so P equals Q, and Q equals -1, so P equals -1. So this one actually has 2 correct answers, and I would take either one on this one. So what we're looking for here is the transitive property of equality, right? So this equals that, so therefore this, the first thing equals the last thing. So that's definitely transitive property of equality, but it's also a little bit of substitution here. So right, if I know P equals Q, and I know Q equals -1, then I can take P and I can plug it in for Q and get that answer. So substitution would be correct here as well. Either one of those would be good on a test that I would take. X plus 2 plus 3 equals 7. So x plus 5 equals 7. So notice what we're doing here is we are taking this part and we're combining it and turning it into x plus 5 equals 7. So if we're looking at our list of things, the one we really want to say is 1 is addition, but it can't be addition because addition means we added something to both sides. And here we have a 7, here we have a 7, so nothing got added to the right side either. So this one's actually going to be one that's not on the list. It's going to be our 13th, which is going to be just to simplify, right? What did we do by combining 2 and 3? We just simplified the problem a little bit. So we get x plus 5 equals 7, so we just did some simplify there.